Hello everyone and welcome back to our videos. Today we will talk about the hydraulic system components and we will start with the reservoir. We have integral reservoir or inline reservoir. The integral reservoir, this type has no housing or case of its own but is merely a space set aside within some major component to hold a supply of operational fluid. Inline, this type has its own housing, is a complete within itself and is connected with other components in the system by tubing or house. Like this. It has its own housing. Many reservoirs are equipped with a dipstick or glass side gauge by which fluid level can be confidently and accurately checked. Reservoirs are either vented to the atmosphere or closed to the atmosphere and pressurized. Unpressurized reservoirs, we have aircraft that fly at lower altitudes normally have hydraulic systems supplied with fluid from unpressurized reservoir. These reservoirs must be large enough to hold all of the fluid required for any position of the actuating cylinders. This unpressurized hydraulic reservoir, and as they said, they found on airplanes that fly only at lower altitude. Here we have the fin to the atmosphere, and this is the difference between the pressurized and unpressurized. The unpressurized is vented to the atmosphere. What about the pressurized reservoirs? Jet aircraft that operate at altitudes where there is no enough air pressure to assure a positive feed of fluid to the pump have pressurized hydraulic reservoirs. There are three ways of pressurizing these reservoirs and using a variable displacement hydraulic pump or engine bleed air or by the use of hydraulic system pressure acting on a small piston in the reservoir. An aspirator is installed in the return line to the reservoir. Fluid flowing through the aspirator or venturi, it draws either cabin or ambient air pressure by jet action into the reservoir, thereby pressurizing it. A pressure regulator maintains a pressure between 30 and 35 psi in the reservoir. Another system uses bleed air from the aircraft's turbine engines to maintain a pressure in the main hydraulic reservoir of 40 to 45 psi. A third type of reservoir may be pressurized by a hydraulic system pressure acting on a small piston. As we see here, this is the piston and cylinder. And as they talked, the pressure of a hydraulic system can be used to pressurize the reservoir. A pressure reduction mechanism is used to lower the high system pressures to allow pressure suitable for the reservoir. A 5-to-1 reduction occurs if the area of the input portion of the piston A is 1 square inch and the area of the piston portion bearing on reservoir fluid B is 50 square inch. This the piston A, B, and this the piston A. The second component is filter. Filter is used to keep the system clean from contamination. And here we have our filter. One of more efficient types of filters used in aircraft hydraulic systems is made of specially treated paper folded into plates to increase its surface area. Types of filters. The first type, macronic type filter. The second type, two-stage filter. And the last type, cono filter. The third component, pumps. The pump doesn't create the pressure, but the pressure is produced when the flow of fluid is restricted. Pumps. Hydraulic power is transmitted by the movement of fluid by a pump. The pump doesn't create the pressure, but the pressure is produced when the flow of fluid is restricted. And knowledge of how an electric circuit works helps in understanding the hydraulic power. This is or this we take it from the book to make sure what I told you. Types of pumps. We have hand pumps and powered pumps. The hand pump, a single action pumps, move fluid only on one stroke of the piston, while double action pumps move it on both strokes. Double acting pumps are the ones most commonly used in the aircraft hydraulic systems because of their greater efficiency. Powered pumps. The only function of a pump is to move fluid through the system. There are two basic types of pumps, those having a constant displacement or variable displacement. Pumps may be powered by an electric motor or an engine accessory section. The constant displacement pump moves a specific volume of fluid each time its shaft turns. It must have some form of regulator or relief valve in the system to relieve the pressure that builds up when the pump moves more fluid than the system can use. Constant displacement pump contain several different types. The first type, gear pumps. The second type, gear rotor pumps. The third type, piston pumps. And the last one, vane pumps. Gear pump. The gear pump is one of the most generally used types of constant displacement pumps for medium pressure hydraulic systems. And this our gear pump. Gear rotor pump. The gear rotor pump is a combination internal external gear pump. The 6-tooth spar type drive gear is turned by an accessory drive from the engine, and as it turns it rotates 7-tooth internal gear rotor, and this the gear rotor. Piston type pump. High pressure hydraulic system often use a fixed angle piston type pump. These pumps usually have either 7 or 9 axial drilled holes and a rotating bronze cylinder block. The last type, vane pump. Some hydraulic systems require a pump to move a relatively large volume of fluid, but do not need to produce a very high pressure. For these applications, the vane pump may be used. And this, the vane pump.